Hey there. Thank you for checking out my submission for the Agent Academy Hackathon Special Ops track titled Calamity Agent Weather and Fire Alerts. It's a cloud native system designed in Copilot Studio featuring a custom MCP server and web API to get up to date weather and fire alerts from authoritative sources so people can reduce their risk of being in harm's way. Calamity can get the latest warnings from the National Weather Service given a location. It can also get near real-time data from NASA's Fire Information Database via NOAA satellite imaging and show this using Azure Maps. Finally, Calamity grounds responses with clear disaster preparedness information from FEMA's ready.gov website. So let's check it out. In Copilot Studio, we have our agent already loaded. We initialize a custom topic by asking for current conditions. Here, the agent prompts us for a desired location with this adaptive card. Next, we have another card that asks us if we want weather or fire alerts. We can click either the picture or the button. Both selections are saved in variables, which the agent confirms on screen and then processes the intent to trigger its MCP tools. It converts the location to geographic coordinates. It calls the geocode tool, which makes a request to the Web API proxy and ultimately in Azure Maps. Then, since we chose weather, it takes those coordinates and passes them to the Get Alerts tool to query the NWS service. Last, a map is requested and the affected area is drawn in the chat. So next, let's pull up an active fire area. Here's the data from VIIRS, an imaging system on the NOAA 21 environmental satellite. It images the Earth across 22 bands of light wavelengths and can detect and measure fire activity and strength. So we're going to look at current conditions again, but when we were prompted for location, we provided coordinates. Wildfires can occur in remote areas, so this method can be useful when we don't have a metropolitan region to search. So the VIIRS data is a little different from the National Weather Service alerts since it's based on satellite imaging. Once a response is returned, Calamity calls the MCP server for both the map and the observations and returns that to the user. So let's look at the code. I mentioned that this is a cloud native system, and everything starts with the API proxy to the official services. We're hosting a minimal web API and a .NET Aspire solution, and this is essentially the back end to the MCP server, which is an even more minimal Express API. Both are then deployed as container apps in Azure. The cool thing is being able to test the MCP server directly in VS Code as standalone tools with GitHub Copilot. The final piece are the YAML definitions for the Calamity agent itself. Using the Copilot Studio extension and the author agent, I could serialize the agent and topic and refine its behavior in code. So here, I requested additional guardrails in the agent's instructions. I've wanted to work on a meaningful project like this for a long time, and Copilot Studio allowed me to build it within a time frame that a couple years ago seemed impossible. I am so grateful for each of the contributors to Agent Academy who developed the challenges like MCP and YAML that were essential to this project, as well as Microsoft for offering up the Power Up program and providing an environment to experiment with these tools. It's been an incredibly fulfilling learning experience for me. Thank you for watching and considering my submission for the Agent Academy Hackathon.